And we are live. All right, I just came across one of the most interesting mathematical insights, realizations. It was inspired by my dad viewing a Robert Edward Grant video where he's explaining why 0 raised to the 0 power equals 1. And in my opinion, he did a disservice by really not going deep enough to show the magic of what's going on and to show what's under the hood, because math is a symbolic language that we're using to express certain things. So it's like, what is an exponent? Like, what does that even mean? And it sent me on this little journey of attempting to explain it to my dad, which part of and this is why I love teaching, is because by teaching, I'm learning. I had to be more clear to myself of like, what is going on? And so it was a discovery process. And it relates back to electrical engineering, the ether physics. And one of the things I'm going to be getting at is, if this allows me to draw, I need to not be on eraser, how there's one as the fulcrum. And then there's this polarization of it that can happen in two directions infinitely. And so we can have the positive infinity to the right and the negative infinity. Oops, didn't draw that very well. Negative infinity to the left. But another way to write negative infinity is 0. And what do I mean by this? I mean, we'll just draw it on the bottom here, that x going in this direction to the right is getting bigger, and x going in this direction is getting smaller, but it's 1 over x. So this becomes x squared. This is 1 over x squared, and then it becomes x cubed, then 1 over x cubed. And so this is the progression that keeps happening. And when you have any number raised to the 0 power, it's kind of like applying an infinitely strong deconstructive force to it, like deconstructive interference with harmonics. You can have constructive interference and deconstructive interference with what is it called? Fluid dynamics. Super interesting. Deconstructive interference. And so when we have any number, x, raised to the 0 power, it equals 1, like 10 raised to 0 equals 1. And what is that doing? It's so interesting to understand how there's this polarity here. There's this, we'll put the fulcrum in the middle again, 1. And what are exponents? Like, that's the question. What the heck is an exponent, huh? And it is a way to symbolize multiplication. And so there's multiplication on the positive side, where it is essentially 1, or it doesn't even need to be 1, but it's x raised to the x power, and it's x raised to the negative x power. I'm wondering if it might be more clear if I did it with y, but this is mainly for myself, this video. So x raised to the x means, like, we could write it out as x raised to the 3 is the same as writing x times x times x, whereas x raised to the negative 3 is similar to writing out 1 over the same thing, x times x times x. So here on the right, you're going, as you get the x bigger, x4, x5, x6, the progression, the trend is that it's going infinitely larger towards a positive whole number. I think that's a clear way to really put the language around it. A positive whole number. And then when you're increasing the x value on the left side, can't really see it there. So x raised to the -4, and then you continue with the progression of x raised to the -5 and x raised to the -6. It's getting closer to what number? It's getting closer to 0. So these are the two different poles with 1 in the middle. I'm putting this circle to symbolize it, but it's 1 in the middle. So what's interesting too, I was just thinking about the 1 over infinity, which is 0, right? Raised to infinity, which is infinity over 1, equals 1. I'm trying to think of how we would symbolize that mathematically. 1 over infinity is 0. And then times infinity equals 1. I'm drawing a blank right now on that. So let me see. The other aspect I would love to highlight here that is really cool is to understand how we can write out x squared, and that symbolizes x times x, right? And x over 2. So if we think about this as x raised to x and x raised to 1 over x, that's the 2 is the constant there in terms of the exponential x. I should probably use a y so it's less confusing, but again, it's just for me. I'm going to be able to track this as I come back and watch it. So 1 over x times x. So the point here that I'm looking to highlight is that we symbolically represent this as a square root. So if I have 64, this by default, without anything written here, it's going to be 1/2. So it's saying when I have two boxes, when I have two divisions, two factors, what is the answer to get this number here at the top? And we all know for 64, the square root is 8. It's 8 times 8 equals 64. So 64 raised to the half exponent equals 8. So it's saying when I have this number of divisions, what is the unit of the size of the boxes that I'm going to add up to equal this original number? So this is like this number is like the pyramid, and this number is like the unit, the number of stones, right? So for this, it's simple. It's like a 2-stone pyramid. It's like 8 and 8, and that equals a 64 pyramid. So I want to now use this and extrapolate it with the whole 1 being in the middle and 0 and positive, negative infinity and positive infinity, and negative infinity being 0. That's what's so interesting. So let's see. I love this idea of polarization too, how it's like the ether polarized, and the ether is 1 undisturbed, and then it goes into counter space or the dielectric. And then this one goes into space or the magnetic. And this is just like Eric Dollard was talking about. These are two poles. These are two poles, and we have positive infinity and negative infinity. It's so cool. I feel like there's one more thing I wanted to get at. Okay, so 0. Well, I think it's interesting to note that when we have, this is what Robert Edward Grant was talking about. It's like 0.5 raised to 0.5 and equals something like 0.71 something. And so when we raise a small number to an exponent, it's saying what two numbers do we need to multiply to get to that small number, to that fraction. And it's unlike with big numbers, such as 64, where we take a smaller number, 8 times 8, meaning I'll just continue drawing it out. For this one, we actually need a bigger number. So 0.5 is at the top. We actually need like a 0.7, so it looks bigger. It's interesting to think about this as far as how it's mapped out on the line. So 0.5 would be like here, like 1 over 2, and 0.7 would be, or this is better written out like 3 over 6, and then this is like 2/3, like 0.7 is like 2/3 ish. I know it's 0.66 for 2/3, but it's close enough for what I'm doing. To 2/3, because I just want to see the whereabouts. So 4/6. So as far as being closer to 0, so we're saying 0.7. So these units, when we multiply them together, they're moving us to the left. That's essentially all that it's saying when we really simplify it down, is that when we multiply with fractions, it's driving it greater that way, because it is, the closer it is to 1, the closer it is as the bigger it is as a strong dielectric force. What do I mean by that? I mean, if it's 0.99999, and I might be wrong. This is why I'm saying it out loud. I'm like, what does this mean? Oh, it means like we need closer. We need to be infinitely closer to 1. We need to be infinitely closer to 1 when we have infinite divisions, because we are going to be getting smaller. Because every time we multiply, like 0.999 times 0.999 repeated, it's going to make the number smaller. So it gets smaller and smaller and smaller and smaller. So what it's doing is moving to the left, right? So, but the thing is, if we want to arrive at the 1, which is to the right, wait, so how does this work? Man, trying to track this. So as we get smaller, let's say we have like 0.25, and what he was doing was raising it to the same thing, which that's like 0.25. And then we get 0.125 raised to 0.125. So what's going on is that it's saying a number that's further left is going to have more divisions, and eventually when we have more divisions, like 0.125, so this is 1/4, this is 1/8. I'm trying to think, why does it arrive us back at 1? I think the point is because I'm confused. I'm confused because isn't something like 0.5 raised to 0.5, that's going to equal like 0.7, they said? 0.7. So, and then 0.25 raised to 0.25 is going to equal like 0.75 or something. So it's getting higher. It's like, why is that? It's because well, it's changing both factors, but okay. A smaller number, 1/4 raised to 1/4. It's like, how many factors do we need to get in order to get to that? Like, we get this 4 boxes to equal 1/4, right? So how many do we need to put together? It's like, well, 0.75, because each time it's going to get smaller, so we got to start at a somewhat larger number between 0 and 1, right? Like 0 to 1, like 0.75 is bigger than 0.5. And the thing is, as 0.75 multiplies on itself, it's going to be moving to the left towards 0. So eventually it gets to 0.25, 0.75, 0.75, 0.75. So all these together have a reducing factor, but then when we do it infinite times, it gets bigger. When we do this infinitely, we need it to be 1. Why? This is cracking my brain right now. How is it that x raised to 0, because x is negative infinity. So we did even just like x raised to 100, it would be 100 boxes. And let's say it's 1,000. So it's 1,000 raised to the 100th square root, or 100th root. So 100, you need 10, wait, what? Is it 10? No, 100, because it's multiplication. So something multiplied 100 times equals, it might be easier if I did 10. instead of 100. 1, 10. So it'd be 10 times 10 equals 100 times 10. Wow. So I don't know what it would be. Let me ask ChatGTP really quick. What is 1,000? What is the 100th root of 1,000? Wow, it's 1.015. So that's so interesting. So basically, I've got a big number. I'm raising it to a big root, and it gets close to 1. That means big number here, raised to a big number here, gets closer to 1. And 0 is the biggest. My brain. I'm trying to figure out I want to end it here because it's short and sweet as for the most important fundamental building blocks that blew my mind just coming across this and looking at how the exponents going off into infinity and negative infinity relate to the ether dynamics and the polarization of one. So one is principle. I think I'm going to end it here and I'm going to think about it a little bit more. So, cheers.